Thanks, Jason. And thank you all for having me here today. It's really a very exciting forum. And I think, like most of the speakers, you've been hearing comments like this. The reason why you're hearing that over and over again is that this is an unusual thing that you're part of. The reality is that we all work in some aspect of clinical science overlap. And we know that there's challenges, but we also know that we've taken different pathways to get here. So it's really exciting for all of us to come along and have a chance to talk to you guys as you think about prospectively how you come at those questions. And so we're all just delighted to be here. For me particularly, I'm really glad to have a chance to talk a bit about my own science and career story before giving some suggestions about how to critically appraise the literature. And partly I'm glad to be able to do those things together because my scientific research career, such as it is, has been very rewarding, but it's also given me a number of different perspectives that I draw on when I come to the question of how to read scientific papers or how to interpret the literature. So I think it's a good lesson for both you and me to have to hear a little bit about my background first, because really it's one big conflict of interest declaration. I'm here to give you the background information that you need to be able to critically evaluate my comments and decide whether any of them might be practice-changing for you as you come to the literature. So I published my first peer-reviewed paper as a medical student. I didn't get a grant. NHMRC didn't look at it. I didn't go to an ethics committee. I was on a rural rotation, and we were up very late at night. And for reasons that it's probably best not asked about, we took a standard issue roll of hospital toilet paper, and we unrolled it down the corridor, and we counted all of the sheets that were in it, because the wrapper said there were 1,000 sheets in it, but in fact, there were only 996. It was an outrage, and I think you'll all agree that something had to be done about it. So I called the supply department, and I found out how much they paid for a roll of toilet paper, and I found out how many rolls of toilet paper the hospital ordered. They were surprisingly reluctant to give me that information. Anyway, we got there eventually. And then I worked out how many hospitals there were in Australia, and I estimated how much money was being wasted on those missing 4 sheets and some of the things that we could do about it. By the way, this is the kind of research that you might do if you don't have a health economist in your project when you try to do something complex. But I wrote it up, and I sent it off to a journal that seemed likely to tackle this serious issue, and lo and behold, they published it. I'm reasonably certain it has never been cited, and possibly it has never been read. So it was inauspicious, but it was a first toe in the water. As a junior doctor, I was lucky to have some more serious role models in clinical research. I worked in epilepsy units with Ingrid Scheffer, actually, at the Austin, and intensive care units with people like Ronaldo Bellomo, who you've seen in some of the previous slides today. And in both of those places, I found senior clinicians who were devoted to the discovery of new knowledge and to using it directly to make a difference in patients' lives. And they really encouraged me to keep studying things that I was curious about and that I was passionate about. And that took me in some different directions. I wound up with master's degrees in public health and then in ethics as well. And they also encouraged me to follow up on those interesting research questions and case studies, little things that come up but do give you a lot of practice in terms of writing and thinking about an audience and thinking about the kinds of messages that you want to communicate when you have the opportunity to do so in print. I eventually wound up specializing in infectious diseases, and I remember actually the exact moment that I decided to do that. I'd done a cardiology rotation previously, and then I was doing an infectious diseases rotation with an ID physician who was in his late 60s, and he was coming up to retirement. And we finished our ward rounds at the end of the week and sat down for a cup of coffee, and he said, you know, Justin, there were these 3 things that we came across this week that I've never been asked before, 3 questions I've never been asked before, situations that were just new. And he was an experienced guy, but infectious diseases is just like that. I've often sort of quipped a little bit, don't tell the cardiologist I say this, but you know, when was the last time someone discovered a new heart? But we have a new infectious diseases every week. And ID is just like this. There are always new problems coming up. And it hit me that I really wanted a career like that. I wanted a career where I could be coming up to retirement and still being faced with questions that I'd never had to think about before and trying to work them through. So at this stage of my career, I've focused very heavily on tuberculosis, and particularly on the development and evaluation of public health strategies about how we might eliminate tuberculosis. It's now 5 years since I finished my PhD in that area, and I've loved the feeling of being able to develop a research agenda over time, moving on from not just doing one project in an area, but being able to build a portfolio where one project builds on another towards a bigger vision. Sometimes, though, you do just need to be able to take the opportunities they present themselves and run with where they go. Back in 2009, I was working as a research registrar for an ID unit here in Melbourne, and I had a project, I had a plan, it was all sorted out. I was going to do something that was tuberculosis related, and it all just absolutely fell apart. And I had a couple of months of being quite upset about that, because I had my plans and they were gone. And I really wasn't sure what I was going to do. And then the flu pandemic started in Mexico. And because I had the time and space, and we were thinking about an issue that was emerging, we had time to develop a prospective study that was in place before the first case touchdown in Melbourne. And we were able to quickly publish a descriptive case series of the first 100 patients who were admitted to hospital. Because we then had done this basic work, we found ourselves being approached by a number of other researchers in different areas, and eventually over the next 2 years that led me into research into influenza and pregnancy, into the impact of antiviral medication, into intensive care admissions and influenza vaccines. The most fun and unexpected piece of work I got to do came a year or so after that, from some basic T-cell researchers who had been able to identify the strain of the flu that caused the 1918 flu pandemic. And for those of you who haven't heard the story, they did that by exhuming some graves in the permafrost in Norway of people who had died of the flu, and were able to reconstruct the 1918 virus. And they'd worked with other researchers who had reconstructed viruses from other pandemic flu strains in 57 and in 76 and a few of the other influenza strains. And I was able to provide them with some blood samples from patients who'd recovered from the 2009 flu pandemic, and showing ultimately that those patients' T cells responded very strongly to all of the strains that had caused pandemic flu over the last 100 years, but not to the years in between. And so that's led them on to some really interesting research around finding common epitopes and perhaps developing a universal T-cell-based flu vaccine that will work against whatever the next strain of pandemic flu might be. So that's something very far away from my area of expertise, but that I was really privileged to have the great academic pleasure of playing a really small part in through participating in collaborative research. So even though influenza was a great and a really productive diversion for me, I did come back to TB and being part of a more general infectious diseases team. My research now is quite broad around TB. I do a lot of mathematical modeling and public health, but also collaborative research with TB genomicists and basic researchers of a number of different kinds. As part of the role that I now have in the infectious diseases unit, one of the things that I've done for the last 5 years or so is coordinated a weekly journal club. I think I got that job just because I was available. But as I look back over the history of things that I've done up to this point, I think my background's left me reasonably qualified to run a journal club. I've got some degrees in ethics and public health and in mathematical modeling and clinical practice and research of all of these different kinds that, to me, bring a range of different perspectives to the articles that we talk about. I think in this audience I can admit how much I love my journal club, which my wife insists on referring to as my nerdy club for nerds. I suspect that all of you would, you could all be in my nerdy club for nerds, couldn't you? Good, all right, I'll let her know. I love it because it's a chance to meet every week with particularly the junior doctors, students, pharmacists, anyone else who wants to come along. It's an opportunity for us to work hard on the practice of reading and interpreting literature together. And for me, it's much more about mentoring people in how to think about articles and how to think about research than it is about extracting information from them. We know that there's a huge turnover in scientific knowledge, and there's rapid redundancy in most of what we read, but it's our attitude towards the scientific literature that carries over. It's our attitude and our approach towards critical evaluation of information as it's presented to us that informs our careers wherever they may go. So it's a real pleasure for me to sit and do that with our junior doctors regularly and our PhD students, but that also means that it's a real pleasure for me to come and have the opportunity to talk a little bit about that with you guys here today. So at this point, I think you know enough about my background to understand something of my own biases and perspective, which I hope will let you hear my thoughts about interpreting the literature with an appropriate degree of skepticism. So here are my top tips for how to best interpret and critically analyze scientific papers. So the first thing is you need to get the environment right. Now, really, this is not about flowers and candles, but it's about having a regular time with interested and diverse people, and food really helps. You can read scientific papers on your own. It's nothing to be embarrassed about. We all do it. Okay? Nonetheless, there is real value about coming together regularly with other people to look at articles. And so I really do want to encourage you somewhere in your professional lives to find a group of people that you can reflect on the literature with. So what does a good environment for reading papers look like? Well, there are a few key components that we know about. And of course, it should be a surprise to no one to know that there is a peer-reviewed literature on how to run good journal clubs. And so we know that the single most important factor in successful journal clubs is having food present. In our journal club, I mean, the other one, of course, is to make it mandatory, but I thought I'd focus on the food. In our journal club, we keep it very simple. We have a roster where the person who presents the article also brings along some food. I think it's a good option because a lot of hospitals and places that you might have worked in the past have relied on industry sponsorship for this kind of meeting and to provide food. And I think it's actually quite important for us to maintain a high degree of independence in all of our activities around the medical literature. You also need a few structural things in place, somebody who's going to coordinate your meetings and a regular time and place. Having the right people there is also important. Now, if you do have people with specific technical expertise in areas like biostatistics or clinical trial design, of course, those are great assets, and you absolutely should make use of them. But what's much more important, in my view, is to have a core group of enthusiastic people who have some similar interests to guide the kinds of things that you're going to look at. The more you read papers together, the more your own expertise in all of those technical areas can grow, and you can build up your own skill set in those things. The second thing to say is that you don't need to read everything. So here's a slide that could be a little bit depressing. In just my own tiny little niche area of tuberculosis, Google Scholar told me last week that there were over 27,000 articles published in the first 9 months of the year. You might find that number a bit overwhelming. I actually find it quite liberating because it is actually just too big to read. You cannot read everything. You can abandon that idea. Okay? That means you need to have some selection and some curation about what you're interested in and what you will read, even for those of you who wind up in a focused subspecialty area. Now, our journal club meets weekly, and we're interested both in the content of articles, but really also about learning and critiquing the methodology. That takes a lot of time, and so we typically spend an hour on a single paper. It's a great exercise, it's very valuable, but you just can't do that with many articles. You can't devote that much time, but the training and critical thinking that you get from spending some time in deep reflection is going to carry over, and you will get much quicker at identifying recurrent issues and working out what the key messages are from the articles. It's also important to remember, I think, that reading the literature happens at a lot of different levels. Every month I scan the titles of 5 or 6 key journals that are relevant to my field. I have email alerts on topics that are particularly of interest to me. And as well as the primary literature, I also look for systematic reviews and commentary articles because they give me overall perspective on how other people are summarizing the field. Now, even if you do start reading a paper, it's also worth knowing that it's okay to bail out. you're not committed entirely from the start. I know at this stage you've already gone to a lot of effort. You know, you've found an article, it's got an interesting title, you've pulled it out, maybe you've even got a physical copy of it. But your time is precious, and you don't want to waste it by reading something that actually won't reward you sufficiently. So for me, in order to help me decide whether an article is worth my time, I have a series of questions that I ask that tell me, can I stop reading this article? I've started reading, can I stop reading this article now? And so basically what this does is works through those questions sequentially, starting from the top and working out who's going to make it all the way down to the end here. And the first question comes right at the beginning, looking at the abstract and introduction, which is, do I care about the study question? A really important one to start with, for two reasons. The first is that you are allowed to specialize. I don't need to read every new article that comes out in neurology or astrophysics. Doesn't mean the questions are bad, but it means that I have chosen to narrow my focus unless there's something of just amazing general interest that I want to have a look at. The second reason, though, is that sometimes, unfortunately, researchers just ask the wrong question. It is a shame, it wastes everyone's time, but it does happen. And it can happen for a lot of reasons. One reason can simply be that research can take a long time to complete and the field can move on. And if you've done a retrospective study that compares two treatments, both of which are now obsolete, well, however well the study's been done, it's unfortunately not going to be priority reading for me. So if the question matters, then I move on and I ask whether the study is designed to answer or at least to illuminate the question helpfully. So following hot on the heels of asking a useful question is designing a study that has a reasonable probability of providing a meaningful answer. Now this is rarely absolute. You've heard in this last session about some fantastic randomized control trials, but sometimes a well-designed observational study can provide compelling support for a hypothesis. There's a famous paper that some of you may be aware of looking at randomized control trials of parachutes, which points out in a lovely tongue-in-cheek way that some scientific questions really should not have a control group. Methodology should be designed to appropriately investigate and ethically provide an answer to your question, and critical design flaws can mean that papers can provide more heat than light sometimes. As an example, I looked at a paper last year which asked the question of whether getting an infectious diseases physician to see patients who came into hospital reduced mortality. Okay? Now, as an ID physician, I think that's a great question. But when I got to the methods, I found that the study was retrospective, and the problem was that getting an infectious diseases consult in this particular hospital took about 2 days. And the condition they were looking at was one that people had a very high risk of dying quite soon after coming into hospital. So by definition, it meant that anyone who got an infectious diseases consult had survived through that high-risk period. Okay? This is called an immortal time bias because there's a period of time that one of your groups can't die. So it's problematic, and it meant that the results were something that I didn't trust, even though I'd really like to believe them. So if the design's good, look at the results and check that it's actually been conducted as planned. Major protocol changes are sometimes needed, but they can destroy a study. If you design and power a study for 1,000 participants and then you have a lot of trouble recruiting, as was asked before, and you wind up with 40 patients in your study, well, I'm sorry, but I'm not going to be interested enough to continue because we know that that will have fatally undermined the question and the way that you're trying to answer it. And finally, if they get through these hurdles, you can look at the results and see what they've found. Now, by this point, you're probably committed to finishing the article, but sometimes results don't encourage you to read the author's conclusions in great detail. Do remember that statistical significance is not the same as being scientifically or clinically important, and so there can be very real differences found that are not meaningful. And so when you come to the final question of whether it will change your thinking in practice, you can see that it won't. Point 4 is do not be afraid of the statistics section. Okay? Junior researchers often find statistics sections of papers a bit of a jungle, and as has been said in our previous talks, it's frequently because we're not well trained to think about statistics. Okay? Can I tell you, though, don't skip over this. Don't think that even if you haven't had a lot of formal training that you should skip over this, or even worse, assume that because something has been published, the statistics are fine, that somebody's looked at it and that's okay, and you can just get on to the rest of it. You don't need a PhD in modeling or statistics, and don't let those of us who do intimidate you about this. You do need to learn about the common techniques that are being used statistically. And as I read, I like to ask myself what other ways the authors could have used to test particular hypotheses. It helps you to think critically about not just whether the approach is okay, but actually whether it's optimal. Wiki statistics is your friend. It can give you some very good, simple explanations that help you into unfamiliar terms, which we all come across as we read. Point 5 is that when you're reading the scientific literature, think of it as an extension of conversation, not as a lecture. This is not about final and unquestionable facts. And if you're reading an article, you are part of that conversation. If something's not clear after you think and talk it through, we'll write to the authors and ask. You might also write to journals. Our journal club has published this series of letters over the years, which further the conversations that come up around that table. And the best part of this is that you can also continue the conversation by being stimulated to do more original research yourself and encourage other people to keep that conversation going. Point 6 is please review papers as well as reading them. My wife is an editor who works mainly with books, and so we often talk about the factors that help people to become better writers. And one of the things that we think about all types of writing, whether it's novels or scientific reports, is that a greater degree of expertise in any area of this cycle really helps. In this case, the more you read, the better you'll review. And the more you review, the better you write, and the more you write, the better you read papers. It's a virtuous cycle, and anywhere you break in is worthwhile. Other ways of engaging with this cycle are really valuable as well. Learning yourself to do good, solid, systematic reviews of the literature are very helpful. For me, over the last couple of years, becoming an editor of a journal has also given another whole level of insight, and I've immediately seen the benefit in the way that I read and review papers once I started to get the big picture perspective that comes along with that. And finally, I want to bring this potted summary to a close with this last point, which is that you really need to keep having fun as you read scientific papers. Don't take this all too seriously. We're all learning together as we read and write and learn. We're all learning together as we try to better understand what we're doing and we try to provide better care for our patients. And this is a good and a valuable enterprise. And so I'm really grateful for the chance to be part of that project here and to continue the conversation with you afterwards. So thanks for your time.